Hey everybody, welcome back to Advent of Code Day 10, series where I continue doing Advent of Code problems until I don't feel like it anymore, and I'll be honest, yesterday almost knocked me out, but I'm gonna give it another yesterday was a rough one, okay? I didn't love it, I don't love it, but I'm here, and I'm gonna try day 10, and God willing, we will make it out the other side. So, no, yesterday was not the quantum beam. Yesterday was the finding a valid rectangle on a tiled floor. Yesterday was rough. Yesterday took me like an hour and 15 to solve, which is a little longer than I really wanted to spend on it, but what are you gonna do? Alright, let's jump in. Day 10, factory. Just across the hall you find a large factory. Unfortunately, the elves here have plenty of time to decorate. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. All that remains of the manual are indicator light diagrams, button wiring schematics, and joltage requirements for each machine. Hey JPJ, thank you so much for the resub. For example, the manual describes one machine per line. Each line contains a single indicator light diagram in square brackets, one or more button wiring schematics in parentheses, and joltage requirements in curly braces. To start a machine, its indicator lights must match those shown in the diagram, where a dot means off and pound sign means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So an indicator light diagram like off, on, off means that the machine has 4 indicator lights which are initially off, and the goal is to simultaneously configure the first light to be off, second to be on, yeah. You can toggle the state of the indicator lights by pushing any of the listed buttons. Each button lists which indicator light it toggles. Where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator light either turns on or off. You have to press each button an integer number of times. There's no such thing as 0.5 presses, nor can you push a button a negative number of times. What? Yeah, I'll be back. Okay, sorry. Sorry, I know we were right in the middle of solving puzzles. I had to run for a second. You can toggle the state of indicator lights by pushing the listed buttons. Each button lists which indicator lights it toggles. Yeah, so a button wiring schematic like 034 means each time you push that button, the first, fourth, and fifth indicator lights would all toggle between on and off. If the indicator lights were blah, pushing the button would change them to be blah instead. Because none of the machines are running, the joltage requirements are irrelevant and can be safely ignored. You can push each button as many times as you like, however, to save on time, you'll need to determine the fewest total presses required to correctly configure all indicator lights for all machines on your list. Few ways to correctly configure the first machine. You could press the first 3 buttons once each. Well, so the thing to observe here is that pushing a button twice just reverses pushing the button. So you're either pushing every button 0 or 1 times. So that's not too bad. However, the fewest button presses required is 2. One way to do this is by pressing the last 2 buttons once. The second machine can be configured with as few as 3 button presses. The update's gonna have something to do with the joltage. Yeah. Alright, so, let's go ahead and get our puzzle input so we can parse it. I'm gonna leave this up on screen for a second. Fewest button presses total, okay. With open text. Actually, I'm gonna use the sample input. These inputs have been kicking my ass a bit, so let's start with the sample input and we'll solve the other ones afterwards. So goal is parts 0. 1 up to -1. Zero if x is equal to period else 1 for x in parts. Okay, so that's my goal. Print goal. Let's see what we're getting as we go. Complicated parsing always feels like it benefits from taking the reading slow. Okay. Next is the list of are any of these longer than... Are any of the original ones longer than... Yes, these are longer than 8. I can probably use a bit field for this. That's probably the easier way to do this. One, two, four, yep. Okay, so we're starting from the left, yeah. Okay, cool. Alright. And then for each of these, basically this is what will happen if you push each of the buttons. So buttons equals buttons equals a list made up of parsing each button configuration. Nemo, thanks so much for the resub. For X in int Y, for Y in button, strip off the first and the last, dot split on comma. A plus equals one left shift X, return A. Then finally joltage isn't no longer needed, or isn't currently needed, but we will probably want this information. Okay, so I have that information. Print goal and buttons. Let's see if we're getting what we want here. 8, 10, 2 and 8, yep. 2 would be 4, yep, 4. Okay, so it looks like that's doing the right thing. And basically the question is, what's the smallest number of them that I can combine to get the right answer? Best equals len buttons plus 1, I guess. And then for I in range 0 up to 1 left shift by length of buttons. That seems okay. Yeah, I can do that. Okay. Sure. There you go. Plus 1,000. For J button in enumerate buttons. If, oh, you're fine. If I and 1 left shift J, I know and has like weird precedence rules in Python, does not equal 0, then res invert button. Oh, I'm sorry, I'm writing this like I'm writing in a different language. I like switched into like C mode or JavaScript mode or something. If res is equal to goal and count and count is less than best, best equals count. Two, 3, 2, is that right? 2, 3, 2. Yep. 7, 409. Giddy up. Okay. All of the machines are starting to come online. Now it's time to worry about the joltage requirements. You better fucking believe. Each machine needs to be configured to exactly the specified joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the joltage levels. Machines each have a set of numeric counters tracking its joltage levels, 1 counter per joltage requirement. The counters are all initially set to 0. So joltage requirements like 3, 5, 4, 7 mean the machine has 4 counters, which are initially 0, and that the goal is to simultaneously configure the first counter to be 3, second to be 5, third to be 4, and fourth to be 7. The button wiring schematics are still relevant. In this new joltage configuration mode, each button now indicates which counters it affects, where 0 means the first counter, 1 means the second counter, and so on. When you push a button, each listed counter is increased by 1. So a button wiring schematic like 1-3 means that each time you push that button, the second and fourth counters would each increase by 1. If the current joltage levels were 0, 1, 2, 3, pushing the button would change them to be 0, 2, 2, 4. Configuring the first machine's counters require a minimum of 10 button presses. One way to do this is by pressing 3 once, times 2 times once and twice. Configuring the second machine's counters. Okay, so now we're doing just joltage, no longer, no longer are we doing... Yeah, that's different, man. That's a different idea, huh? That's a different idea. Yeah, I think we're not doing that part anymore. I think we've evolved beyond the need for all of this. Do they all start at 0? All initially set to 0, yeah. So, I think you want to try them greedily. You get fewer button presses if you press buttons that affect more than one counter at once, so I think you want to do... I think you want to try... That's certainly the order you want to try them in. Okay, don't love this. Yeah, okay. Okay, so I've sorted them by the size of the lists. Is there ever a situation in which... This is either... I don't think this can be solved greedily. Like, my instincts tell me that this can't be solved greedily and I need, like, a dynamic programming algorithm. I also think, by the way, I'm not going to solve it this way, but I also think this might have, like, a matrix solution. I'm pretty sure this can be solved with matrix multiplication if you are better at linear algebra than I am. This does have a matrix. Hold on, I need to. I like need to do a small amount of reading on linear algebra. Matrix multiplication. I know I shouldn't have to Google search matrix multiplication, but I would like to read the article just to refresh myself. I need to like picture this problem. I don't think it has a simple matrix multiplication approach, actually. I don't think it does, because... Is this really just finding an eigensystem in a matrix? I'm sorry, I'm 15 years out of linear algebra courses, but this feels like it's finding an eigensystem. I don't think it is. I think I might be wrong. I'm going to abandon this line of thinking, because I think this line of thinking causes me to take a lot longer to solve the problem in a harder way. I started as a math major in college, so I've taken linear algebra. I did not do well at linear algebra, despite the fact that now as a computer scientist, I use linear algebra a lot more. I think I can solve this with dynamic programming. I think I can solve this with dynamic programming. Can I solve this with dynamic programming? What are like some of the larger numbers in this? 35, 34. I think I can solve this. I think I can solve this fast enough with dynamic programming. So basically the idea is I have a target. So this is my target is my goal. I have my list of buttons. And basically what I'm going to do is I'm going to figure out what's the maximum number of times I can press the first button. I'm going to try all combinations of that as well as the rest of the buttons. I don't want to do that. I don't want my solution to be so bad that I have to leave it running for a long time. I would not be satisfied with that. Otherwise, we would have finished yesterday 30 minutes early, and I would have just let it go. Goal. Buttons. So first thing I need to do is I need to figure out what's the maximum number of times I can hit each button. Oh, I need to know my state so far. State, goal, buttons. Okay. And my state that I'm starting at is 0 times len of goal. The most times I can press the first, so B is buttons 0. If state is equal to goal, if state is equal to goal, yes, return 0. It takes 0 button presses to turn the correct state into the goal. If if the length of buttons is 0, return math infinity. No way. Otherwise, we're going to extract the first button. And I'm going to look at what's the best. So, most times I can press the button is equal to the minimum across goal x minus state x for x in B. So that's the most times I'm allowed to press the button. I feel like I'm going to want a memo table. I'm not ready to commit to that yet, but I'm just going to write that down. So that's the most number of times I'm able to press this button. And I think I want to try in reverse. So I'm going to say for I in range I'll just do 0 up to most, and I'll do a subtraction. Best is math infinity. B is most minus I. Solve. Solve for it's going to be a list where oh, if I solve it from the bottom up, this actually makes my life a little easier. I might do that just because it's going to make my life a little easier. Basically, I can say... Does Python do pass by reference or pass by value? I think it's pass by reference, right? I don't want to clobber this array. Circle buttons, but chop off the first one. Sol is less than... This is going to be a worse search if I don't start from the top. Which makes me a little upset. I don't know about this one, boss. I don't know about this one, boss. I got the answer, okay. Well. Yeah, I did not expect that to be... I didn't expect it to be fast, but this feels a little slow. Oh, that's not a good sign. I do think this is a linear algebra problem, and I'm not knowledgeable enough about linear algebra to know how to solve it efficiently. Fuck. I didn't memorize. I could try memorization. The search space is massive though. I don't think memorization is going to help a whole lot. I cannot imagine this doing a single fucking thing to help me. If anything, it might slow it down. I'm gonna let it run for a second while I'm thinking about this. I do think this is a linear algebra problem. They just didn't know how bad at linear algebra I am. You could certainly... Matrix multiplication's invertible, right? That feels like a question I should definitely remember the answer to. Because here's what I'm thinking. I'll say what I'm thinking rather than just doing. What I'm thinking is that if you take a matrix that represents what counter each button maps to, and you multiply that by a sequence of button presses represented as a vector, that should tell you what the final configuration of the counter is. So you should be able to multiply by the matrices inverse to get the number of presses needed. But the problem is I don't think this is invertible because it's not guaranteed that you can go backwards, right? Like, I don't think this is invertible. Like, if I take a matrix and I multiply it by information about what buttons I've pressed, I will get information about the counters. But there are multiple button presses that could lead to that counter, so this feels like you can't invert that process. I think the real observation that I'm missing here is that a dynamic programming solution is probably correct, but I should not need to search for every number of buttons at each level. Because right now, solving this one right here is taking, you know, every possible number of button presses for the first button, every possible number of button presses for the second button, and so on. And that is massive. So I think the intuition here is not searching for all numbers of times you can hit that button, but rather being confident that you can only press the button 0 or P times. And I have not figured out the intuition that tells me that I can do that. Like, I can try that. I can try only allowing myself to press each button 0 or all times, but I think I can concoct an example where that's not correct. I'm missing a key observation here. There is an observation that I'm missing that makes a dynamic programming solution work. I'm not seeing it right now. Yeah, this memoization thing slowed it down. I'm looking back at the test cases. There are some observations I'm not seeing. Like, no, I'll use libraries if there's one that feels like an obvious solution to me, but most things I know how to code myself faster than I would be able to find a library for it. Trust me, if we actually go down the linear algebra route, I'll be busting out NumPy, no problem. But, there's gotta be an observation I'm just missing here. Hey, welcome. Maximum of 10 button presses. I certainly could... You know, maybe the problem here is that I'm just not branch and bounding. Let me try something. So I'm branching, but I'm not bounding. And I wonder if just adding a simple bound would help. So essentially what I want to do is, when I find a solution that takes X number of presses, I don't want to even explore a solution that might take more presses, right? So how do I want to write this? Let me confirm that this still works with this one. I'm not sure the math is right here. And man, is it not speeding anything up right now. I don't want it to be global. I want to pass forward improvements to it. I mean, my answer is almost always, if you've solved the problem already, I don't want to hear it, but I don't really care if you want to talk about it. You're not going to break my heart. The base game is fine. Some of the stuff in the DLC is a little harder, but... This is, like, terribly inefficient, and I don't like it. But I don't have a better solution at the moment. Yeah, I understand what you're saying. I was thinking about that as well, about trying to isolate buttons that need to be pressed and figuring out in advance how many times they need to be pressed. That's what we would refer to as a heuristic speed up, though. It's a great solution if that is a pattern that's demonstrated throughout all of the test cases, but all it's going to do is it's going to speed up the random test case that has that feature in it. This is not right. This is not an improvement, and I'm trying to figure out what I'm doing wrong. So this is me saying, hey, if you can't solve this problem in this number of moves, I don't care, because it's not going to improve my solution. The goal is to skip the checks that aren't going to improve my solution. That's what the bounding option is doing here, is it's saying, hey, if you've already done 11 presses and the best I've seen so far is 10, don't bother. Don't bother going in this direction. You're never going to improve my solution. You could probably also do that speed up at a button level as well. Like, if you recognize that you're... So the max of this is... Does that speed it up? This basically says, look at the state you're in right now. In a perfect world, you need at least this many button presses. And if that is more than the bound I'm putting on you, then there's no solution in this direction. Yeah, I thought about greedy at first, but I had a solution I wasn't happy with, so... Or I had a case... I was coming up with cases in my head that didn't work. I feel like if I write some comments to explain this, I might hear a problem. This is the number of presses we're trying. If that number of presses is larger than the bound, then we skip this case. Otherwise, we build the case we would reach by pressing the number of buttons that time, and then we say, solve for the state that we reach with one less button available, and we place this bound on ourselves. Best minus P. So best is the best I've seen, minus the number of presses I'm making to get there. If this improves our best, then our best is the solution, and we go ahead and lower our bound as well. I have two variables that are kind of doing the same thing, but I just don't care that much right now. Not sure that I see the obvious way to improve this solution, because right now this is too slow. For sure. I feel like all of this list mincing might be causing me some of my trouble. Let me mess around with that a bit. Oh yeah, for sure. So I think this fixes all of the... I still have this, which is nasty. I wasn't even aware there were special forks of VS Code. I just use VS Code. There is probably a linear algebra solution. I've circled that drain several times to no avail. Still getting the right solution. I love that I have the right answer, it's just too slow. I mean, I guess there's worse problems to have in the world. Yeah, no problem. I don't think this is lights out. The previous problem was lights out. This is not lights out, though. It's not, because lights out is just inverting a signal, whereas this is summation. So it's not an invertible problem. Let me just think for a moment before I maybe give up on this for now. Because I do want to play games. I don't want to sit here for... I don't want to sit here for another hour on this. Because, yes, lights out is just doing matrix multiplication under GP2. So, like, you can just code that up as a pretty simple matrix multiplication problem. But this isn't, because it's doing summation, which means the problem's not invertible. Like, because we're summing up the values... I can't take the solution and go back to a number of button presses because there's many different button presses that lead to the same solution. How's this going? We have what I think to be the right answer, but it's far too slow. So, good, not good, it's somewhere in there. There is maybe another way? Yeah, part one was just lights out. That, I mean, I coded that up as complete search, but I could have done it with matrix multiplication. I'm confident there's a linear algebra solution here. I'm confident that there's a linear algebra solution. I just don't know enough linear algebra to know what it is. For some reason, I keep thinking it has something to do with, like, solving the eigensystem But I don't think it's solving the eigensystem. I don't see how that gives me the answer I want. And even if the matrix is invertible, I don't see how that would even give me the right answer to be able to just do inverse matrix multiplication. Give me a moment. I just want to think about this for a second before I don't know, bail. I think it's possible that... I mean, I'm sure if I leave this running for 40 hours, it'll come up with the right answer. Make a copy of my current state. There is an observation I'm missing. I've thrown every complete search solution I can think of at this. I have organized my input so that it's processing it in theoretically the most efficient way. I've implemented branch and bound to try to limit my search space. I've done all the obvious complete search things. I've even tried to optimize my code slightly. God forbid. Well, I mean, I'm confident this gives me the right answer. I feel confident that this gives me the right answer, so... Like, I don't need to prove to anyone that it does. Like, leaving this running for 40 hours just raises my power bill. It's not accomplishing anything for me. It probably is math that I'm lacking in. Yes. The answer is yes. It is definitely math that I'm lacking in. This is the clever solution is not coming to me. I feel super confident that it's a linear algebra problem, but it is not obvious to me how to solve this with linear algebra. The whole problem is being solved mathematically right now. Yeah, considering we have 157 cases to go through and we have not seen case 2 pop up with a solution yet, who knows? Is this one really so nasty? How many buttons are there? It's really just because of these values being a little larger. These were pretty small values. This goes up to 200, so the search space is way larger. Probably bound harder, right? mean, I guess you can, sure. You can't come in and immediately start backseating and then tell other people not to backseat. That is wild work. That is amazing. And simply the audacity, the incredible audacity on display. The way that I'm bounding now is... There is a second bound that I can put on this, but I'm not sure that it actually saves me any cycles here. Because this bound is essentially saying, like, assume that every button press you're going to make from this point onward is going to improve the one that's the furthest distance away from correct. But there's another thought as well. If you sum up all of the moves that are remaining, like, you know, I need to increment this number by this amount, and this number by this amount, and this number by this amount. The question then becomes, are there enough buttons that affect enough things that the button presses shake out? I don't think that bound actually improves anything. I think this ends up being a tighter bound in practice. I'm upset with this problem because I feel like I feel like I should be rewarded for the fact that I can acknowledge that I recognize that this is a linear algebra problem, but it's not a linear algebra problem I'm familiar with. So I'm not being rewarded for my knowledge. There's no benefit in it for me. Yeah. Yeah, this is the right answer. It's just the right answer in a really dog shit way, because it's just doing complete search with branch and bound. I swear to God, I feel like if I just went through the Wikipedia article and clicked on every one of these different linear algebra topics, I would find one of them that tells me how to solve this. I know that there is something in here. Isn't this just a... Isn't this just solving a system of linear equations? I'm sorry. I'm at the point in the day where I feel stupid. I don't know why my brain won't work. Is it because I'm trying to solve this problem at 10 p.m.? No. That's an excuse. No Johns. I'm just not... I'm feeling especially stupid right now. Is this solving a system of linear equations, though? It's not. It's not linear equations. It's an optimization problem. Those are two different things. No, because this doesn't have... Like, we're not trying to figure out one answer. That's the problem. We're not trying to figure out, like, which buttons do you need to press to accomplish this thing. We know that there are multiple solutions and we're trying to find the optimal one. This is linear programming, if nothing else. This is a problem I feel like I just need to come back to. When my brain is better, I need to come back to this. Am I gonna, like, open up Cplex or something like that? I'm sorry. I'm at the wrong point in my life to open up Cplex. That's simply not happening today. Yeah. Yeah, sorry. This shit ain't happening. Yeah, that ain't happening. Day 10 got my ass. What am I gonna say? Day 10 got my ass. That's fine. I'll come back to this on another day with a better attitude. I'm gonna play some video games.